Now let's continue our investigation of the SSA case and how we're going to use law of sines on this. We've got all the cases laid out, and I want to talk about this case 3, the ambiguous case, which is the most interesting one. This is where the swinging rod, here it's going to be 6 centimeters, is long enough to reach the ground. That's because it's bigger than h, which we already calculated was 4.52 centimeters. It's here. And it's smaller than the fixed beam, which is 7 centimeters. And so it fits here, but you can also kick it out to here to make it. So let's look at focus on that. We know there's going to be 2 solutions, and I'm going to go down, excuse me, and just start afresh from that. Okay, so what we do first is we've got this angle and the side opposite. That's a great thing. That activates the law of sines. Okay, we've got sine A, just kidding, over A. Okay, and so that's sine 40 degrees over 6. Well, is that going to help us? Yes, because we've also got the side opposite this mystery angle. So that's certainly progress if we can get this other angle in the triangle. Once you've got 2 angles, then it's easy to get 3, and then with a side, there's all kinds of methods we could use. So the key is we're going to find angle B, and so it's going to be sine B over little b, which is known, that's 7. And it says 7.02, but I just couldn't quite get it exactly 7 with the sketchpad. Okay, so that's good. So sine B is going to be just 7/6 of sine 40 degrees. And I'll just calculate that out. Okay, and so that's 0.74992. Okay, and then so B, so here's what looks like an unobjectionable step. Oh, I've got an angle that I want to know, and I know its sine, so B is going to be the inverse sine, right? Well, it turns out that that's going to be a little subtle, of 0.74992. Okay, so let's compute that. Now, one of the weird things about this computer is it always does that in radians. Well, maybe there's a setting I don't know about. But I'm just going to multiply by pi, 180 over pi real quick, to get it in degrees, because we really want it in degrees for these geometry problems. Okay, and so it looks like 48.583 degrees. Let's see if that makes sense. If A and B were equal, it'd be isosceles, these angles would be equal. As it is, B is a bit bigger, A is a bit shorter, so it's kind of, if it was isosceles, it would be out here. You come in a little bit, that's going to open up this angle. So this is bigger than the 40. Makes sense. The bigger side, B7, is opposite the bigger angle, the 48. So seems like a reasonable answer, which is always something you want to check. Okay, so it seems like we're getting close to being done. So let's run with this. But we want to keep in the back of our minds there's supposed to be 2 solutions. Okay. So let's keep going though and try to solve this triangle that we've got. So once we have B, it's 48.583. Well, let's check that actually. Let's use Sketchpad. It's not going to be exact because none of these are exact, but let's measure the angle. We might as well. Okay, 48.64. It's pretty close. Okay. So let's keep going. We've got these 2 angles. Now it's very easy to get C, and that's definitely the next thing to do. It's 180 degrees. Well, it won't like the degrees here. 180 minus 40 minus 48.583. Just calculate that out. 91.417. Ooh, if that had been 90, it would have been kind of nice because it would actually secretly been right triangle trig, but it's not. It usually turn out to be 90. Okay, so is that going to help us? Well, let's first check it. Now again, we're not going to be correct to 3 decimal places because this sketch isn't quite exact. I didn't try to do it exactly. But 91.4 something. Cool. Okay, now the only thing here is side C, opposite angle C. Let's see what we can do with that. Well, we could either use cosines or sines. We've got SAS, so we could use cosines, but sines is a little bit easier in terms of the calculation. So sine C over little c is this calculation we did up here, it's the same thing. So we could either use B or A, but let's go back to A because it's a slightly simpler number. Sine 40 degrees over 6. Okay, and so little c, or let's see, let's just clear the fractions. 6 sine c is c sine 40 degrees. And so c is, as with all these kinds of side calculations, it's going to be sine c over sine phi times the length. So this is something you'd always expect from law of sines when you're solving for a side. It's one of the other sides times a ratio of sines. Okay? And now we can calculate that out. Oh yeah, and we know c is 91.417. Calculate that out. Okay. Okay, what did I not do? Can you see what I didn't do? Didn't put it in degrees. Now, does this, the thing is, I immediately knew minus, negative? That doesn't make any sense. Okay, and so let's compute again. There we go. So c supposedly is 9.3315. Okay, does that look reasonable? Well, if this is 7, this is 6. Yeah, it looks like this is about 9 and change, something like that. Okay, so we've got one version of the triangle solved. This version. But how on earth do we get the other version? We know it's supposed to be there. And this is the hard here, is to remind yourself, hey, you go through this process and you start memorizing this, you've only solved half the problem. You got half the points on the test for that problem. That's not a good situation to be in. So the big observation is that if I actually put these together, let me put one more things that can swing on here. If I, if I look at both of them, no, I didn't mean to do that, thank you. Okay. Look at what kind of triangle this forms. These are both two copies of the same swinging rod, just in two places. They have the same length. This is going to be an isosceles triangle. So this angle, which we've already calculated, that was 48.5. That's the same as this angle. That allows us to calculate what this angle is. That's the other possible version of angle B, because this is another possible location that B could be in. And so that's what we need to do, is we start over from right here. We start over. The other possibility is that in fact B is 180 minus, what was it? 48.583. Okay. And we calculate that. Okay. Let me just put it up here because it doesn't want to do it for me. And then we just start over. We have to do the rest of the calculation from scratch. So this moves over and we get this triangle. I usually encourage people, even though the picture where it's all put together is kind of pretty and you can see both the triangles, it can be confusing. I really suggest people draw the big triangle with this knot there. So it's like the one where it's like that. And then the version where the rod is swung over to here. Because it's very important that you're solving two different triangles now. And everything from this point is going to be different. So B is the supplement of what we started with. And then angle C, you do another 180 minus. You do 180 minus 40 minus this guy. And you calculate that out. Okay, so that's now a much smaller angle, which makes sense. That's this tiny angle up here. Okay. And then you do the sines again. And so we have sine C, sorry, over C equals sine A over A. So that is, again, that same sine 40 degrees over 6. And this one now is a different angle, 8.58. Okay, and so C sine 40 degrees is now 6 sine 8.58 degrees. Oh, yep, this is a degrees. These are all in degrees. Bad habit if you get out of doing the degree sign. And we're almost done. We're in the home stretch, don't worry. I know it's getting long. The truth is, these are long problems because it's two problems in one. You've got to deal with that, and you got to not let your subconscious try to fudge it and say, I'd rather not do it. because that's what happens. Okay, and so this is 1.3926. Much smaller for this triangle, where the swinging rod is swung over here, than C was for here, where it was this big number. Okay. So we got two separate triangles, different measurements for angle B, angle C, and side C. And they've just got to be done completely separately. They both start with the law of sines calculation here, and then they run from there. One comment I want to make, I know it's getting long, but where did this come from? Why did we have to do this artificially? Why did we have to observe geometrically that we could swing it over? Why didn't the math tell us? If sine B is 0.74992, what's happening? It seems like, okay, then B is the inverse sine, and then B has to be this. How could it be something else? Well, this is crucial to remember that sine inverse doesn't really deserve to exist. Okay. Remember, if you graph the sine function, that is not something that's supposed to have an inverse. Let me just graph that for us real quick. If you graph the sine function, it doesn't satisfy the horizontal line test. It's not supposed to have an inverse function. And in fact, if I say, what are all the possible angles whose sine is about 3/4? Well, I can pick that off the graph. Right around here, there's one here, about 1 radian, which is the right number in degrees that we got, and there's one over here. Both of those are angles that fit into a triangle. This is about a little more than 2 radians. It's somewhere around 100 and something degrees. They both fit in. And if you're looking at this equation, sine B is some number, that's not just solved by the inverse sine. This gives you the simplest angle. 48.583 is the simplest angle for that. But it could be the supplement of that angle. We discovered a while ago that if you take the sine of 180 minus an angle, it's the same thing as if you take 180 sine of the original angle. That's the symmetry of this guy around this axis right here, which is pi over 2 radians, or 90 degrees. If you draw it on a unit circle, let me draw a little circle for us here. If you draw a unit circle, that's because a point here, oops, boop. That's because a point here gives you the same, here we go, that's going to work better. Gives you the same height as a point over here. Those guys have different angles, but the same sine. So that's sort of the secret thing here. When I said that this is a little dubious to take the inverse sine, you have to do it to get the number, but don't believe that's the only answer. To sine B is some quantity. It's just the simplest answer. The other answer is 180 minus, and that's what we observed geometrically had to exist by looking at the fact that this could swing both ways here. Okay, but the main thing is that you've got to do both triangle cases, and you've got to get all the data for both triangles.